Okay, so just to give you a bit of an overview of what I'll cover today, I'll talk a little bit about some updates in data management and how we interact with science collaborations. It's your science collaboration. I'll then go on to talk about the alert streams and the brokers, the LSST prompt processing, in particular the data products that will be produced for solar system science, and then how you might use those with the brokers. And then finally, if we get to this, we might not have enough time for this, but it'll be up to you to decide if you want to continue. I worked through some of the use cases that were presented by Meg in the Google Doc as to how you might solve some of these problems with the alert broker or in a different way. So we can do this in this session or we can do it later, as you like. So just as a quick introduction, as Mario said, I'm the new LSST data management scientist, or subsystem scientist. I'm taking over from Mario, and I started about 2 months ago in Tucson. I've just relocated to Tucson. I previously worked on the ESA Gaia mission for over 10 years. I worked in the transients and variable star working group. I wrote most of the scientific pipelines for the transient and variable star processing in Gaia. I was involved a lot in commissioning and science validation in Gaia. But I originally come from particle physics. I did my PhD in Atlas at CERN, and I worked extensively in the LHC computing grid project before I moved on to work in Gaia. So just a quick update on the changes in data management recently. As you know, Mario has stepped down. He's now working much more with you guys in the solar system science team. You're very lucky to have him. And so there have been, so I keep thinking this is a pointer. So this is now what you have in the data management science team. So I'm the subsystem scientist, and Colin, who has just turned up this morning, is at the back here, so you know Colin, is the deputy, and he's here at UW. So for those of you at UW, you can always speak to Colin. The subsystem science team contains representatives from each different part of the data management, from the data processing, the software quality assurance, the science platform, the alert productions. It also includes a pipeline scientist, a verification scientist, and 2 science analysts. Colin is partially a science analyst, and Melissa Graham here at UW. And our primary responsibilities are to work very much with the science community and the LSST science collaborations to make sure that the data management system responds to your science needs. And that's really, I think, what drives this team. But also to look for new opportunities as well. I mean, through these discussions, if we come up with new things you'd like to do, things we haven't thought about, it's for us to work out how we would incorporate this into the data management system. Can we do it? You know, what are the scientific gains and so forth? And this team also leads the science validation of the data management deliverables. So if you have new ideas for scientific opportunities you'd like to see in the data management system and the data products with people to talk to, me or Colin or anyone else, and you can also discuss this through Mario. We have in place a communication system for the science collaborations, which involves a liaison for every science collaboration. And your liaison is Mario. So anything you'd like to discuss concerning data management products, Mario is your liaison, and he will come back to this, the data management team, and we will discuss and work through any of your ideas. Okay, so I think Mario showed you this slide yesterday, but it's always good to remind people of the landscape of data management in LSST. You have the telescope, which produces roughly 20 terabytes of raw data per night in the form of images, and this includes the calibration exposures as well. And these images that come off the telescope nightly create what we call the prompt data products, which are transmitted via nightly alert streams. And this is what I'm going to talk mostly about in this talk, the alert streams that come from the prompt products. And we expect something like 10 million of these per night with a real-time latency of 60 seconds. And that means that 60 seconds after shutter closes, if there's been a new discovery, a detection, then you should have that in the alert stream, and that's the goal. These are produced nightly. Then we have on an annual basis what we call the data release data products. These data products are produced through direct image analysis. They involve a more consistent processing across all the products and pipelines with better calibration of the system. The prompt data products come just simply from difference imaging analysis on individual images. We expect to have 1 data release per year over 10 years, and we're expecting to have 2 within the first year. That will probably be discussed and revised. I can tell you from my Gaia experience that producing a data release is an enormous amount of work. And it's not just the processing. It's running the pipelines is actually the least amount of work in producing a data release. So how will you, the scientists, access this? We have the LSST Science Platform. And this will give you access to data releases, both current and previous, so you'll be able to go back and look at the older data releases, and you'll have access to the alerts database, which is where all the prompt products will be stored that are contained in the alert streams. And this will also provide an alert filtering service that we call a mini broker that will allow you to have some sort of broker functionality through the science platform. So just to recap, we group the data product categories into 3 types, and this is described. I refer you to these 2 documents here: the data products categories document and the data products document. The prompt data products are the product of real-time difference image analysis. So it's just an analysis on one image and a template. These will produce a stream of something like 10 million time domain events per night, which we will transmit to distribution networks, also known as community brokers, and they will then transmit them out to the user community. It also contains a catalog of orbits for about 6 million bodies in the solar system, which is what you will be very interested in working. The data release data products reduced single epoch and deep co-added images, and it also includes the reprocessed prompt products. So the prompt data products are produced nightly, but every year we will also reprocess those prompt products with the full calibration and all the information that is available at the time of the reprocessing. These are produced annually through online databases, and we predict something of the order of 20 billion galaxies, 17 billion stars, trillions of observations. So this will be huge. And finally, the user-generated products. This is what you, the community, will add to this. We don't do any classification of events. We do characterization of detections, but things like variable star classifications, shear maps, that sort of thing. This is what the user community will do, and this is what the science collaborations will contribute. And we call these user-generated value-added products. And this is enabled through the services and computing resources at the LSST data access centers and through the LSST science platform.
Excuse me,
yes?
These products will be also somehow included in the LSST database, or
so there is a
third level product?
So you mean the products that you, the users, generate?
Yeah.
So we are discussing that. We are thinking about how, yes, the products that you generate, we could also then put into the database to make available to more users. There's also some discussion about user-generated algorithms that you might come up with. Could they be generally useful, that we might push them back up the stream into the data release procedures if you come up with something that's very useful broadly to the community? Maybe, maybe not. There's no guarantees here, but this is the sort of thing that is open to discussion. Should it provide value?
So when do we get to start doing the user-generated products? Because there is a point of that you have to be on the deck to be able to do this, but there's no deck for me to start figuring out how to write this in a way that I could then interact with it on day one. Like, so right now it's like the DAC is this thing that US people and Chile people will have access to. But when do, like, but the environment and how I would query things are going to be different. So one of the things I'm trying to figure out is when do I start writing those things to actually integrate that in a way that could be used in the DAC? Because I have to, I guess, you've got to update it or set up to be able to use that. And as far as I know, the DAC is not in a state where I could try to do that or figure out how to query things, right? So, is there a timeline for that?
I mean, so what we do have at the moment is the LSST Development Science Platform. And at the recent LSST Europe conference, we did a demo in this, and users could get accounts on it at NCSA. They could log on. They had an environment which brought up a fully configured LSST environment, which included all the pipeline code and which included the reprocessed HSC data with LSST pipelines. And those users were able to write Python notebooks against this and come up and implement a whole lot of use cases. So the Desk Science Collaboration, for example, they've created something called Stack Club. I don't know if are any of you familiar with Desk Stack Club? Okay, Lynn is.
So I've heard of it, but we're at a level where like we're just trying to. We're at the like desk is here.
Yeah.
We're down here.
I know what desk is. I'm trying to put you up to
right.
desk.
So they're not very helpful to us because they're like, let's do this, and we're like, what's an Python notebook, and how do you? What's a Jupyter notebook, and how do you load in the? How do you run the stack?
Okay. I mean, I wasn't sure how interactive this meeting was going to be, and I did wonder if you might have an dev platform set up.
We have none of that.
You have none of that. Okay, so also recently,
actually, that's what we have. This one.
We have Mario.
Well, I don't know if you set up a Jupyter Hub notebook with the.
How about I just say, Mario is your liaison. Mario will solve this problem for you. Yeah.
Sorry, this may be a little in the weeds, but following on the question here about the user-generated stuff. So imagining how the U.S. community is going to be able to work with the data, we're going to have to propose to NASA, and one of the things NASA wants is a data management plan to show that what we do gets archived somewhere. And NASA being the way it is, they're probably going to want stuff in the PDS, although they say the PDS or some equivalent archive. So understanding whether the LSST archive would be willing to take these
is important.
Is important because
I mean there'll be a mix between. I mean, you will write your Python notebooks and your analysis that will generate code. Is it better to just regenerate things on the fly out of what is stored in what is persisted in the database, or is it something generally useful that we might then want to store in the database? So
sure, no, I understand, and this is not
Yeah.
not very much like other NASA,
Mhm.
the kinds of NASA missions that they support. But the planetary community is clearly going to have to use that
Mhm.
that way to get the support. So it's just,
Yeah.
I'm not saying we need.
Sure.
I'm not saying this has to be the answer, but at least the right hand and left hand
Yeah.
should be,
Should be talking to each other. Yeah.
That's this question. If I create a user-generated product, can I make it and host it at the LSST data center?
Yeah.
Push a button somewhere and say, allow everyone with data rights access to this.
Now
You
access
think
this.
that might
Yeah.
satisfy some of the data
Yeah.
management agency requirements.
Yeah. That's something I'll look further into that. I don't think I answered your question fully, but
Is it also true then that whatever goes into this user-generated data center database is going to be visible to the entire project, or is there any privacy with what you're
so
working
the
on?
data. Okay, so this comes on to the subject of derived data products, which I'm not covering in this talk. Perhaps I'll just say that there is the project is working on a document to describe data rights and data access and exactly what this will mean, and there is a large section on derived data products, and this will fall into the category of derived data products, who you can share them with and who you can't.
So user-generated in this case is a subset of derived data products?
It would be a derived, yes, I would, Mario, I would classify it as a derived data product.
Okay, just trying to understand the terminology here.
Yes.
As far as I'm concerned.
Can Colin?
Just to give
Yeah.
a direct answer to Steve's question, you can definitely have private stuff.
You can have private stuff.
Oh,
in-
yes.
in
No
the-
question.
Okay.
So yeah, you can definitely have private stuff. Sorry,
Oh,
yeah.
okay.
I was wondering about that first science case, the deep field NEO, is
Mm-hmm.
that an example? What is that? A method or an idea?
No, these are just examples of what you might want to do.
So like
Should-
deep
should-
stacking.
Well, because that's what I would like to do,
Yeah.
but as far as I understand, it's possible because we don't go beyond this.
No. What that's meant to be is that LSST won't do, for example, shift and stack define KBOs with all the devices on it. But someone in the community can download those images, can take those images and do shift and stacking on their own.
I could do shift and stack as a level 3 on all of the LSST data.
User generated.
If you have enough computing.
I don't think I have enough.
No, you can point to the computer center to do all this stuff without having to download 7 petabytes
yeah.
of
There's
data.
limits on how much cycles you will get.
Yeah,
again,
sure,
right?
sure.
So
Yeah, no, Chad's not gonna do this by himself.
I mean, I
But
can
there's
imagine
also-
typing in a specific orbit and getting 26 magnitude those by stacking together 1,030 seconds.
unless you propose for a special deep drilling field.
Well, that's what I'm gonna do, but I'm a little worried because like if people see that, they'll be like, oh, aren't they already gonna do the DKBO thing with the
No.
level 3 data product?
No. This is LSST will not do any of this science.
Right.
These are examples of the sort of things that scientists might like to do at the level 3 using the data release data products.
So in an older version of the data product definition document, it said 10% of the resources will be devoted to user-generated products. Is that still the case, or is that
That's still roughly the case, yeah, but it's, yeah.
Okay.
Still roughly the number.
The issue you have is you're going to have an order of a couple thousand users, and if you devote 10%, initially I think we started with something like 300 teraflops of compute power. So 10% is going to be an order of a few tens of teraflops divided between potentially hundreds of users. So what you're talking about is effectively something on order of a small server per user. So you're not going to be able to do large-scale reprocessings at the LSST data center. You're going to be able to do kind of the type of analysis that we've been doing here using the Jupyter Hub thing that we set up. Right? So that's kind of the mental model to have. If you want to do something beyond that, there are many resources in the US that you can apply to. You can apply to Exceed, you can apply to whatever the Open Science Grid on the DOE side. And LSST is at NCSA with high-speed bandwidth links to all of these. So that's how you would, for example, do shift and stack across the entire LSST field. You would apply for 100 million core hours on a major NSF resource, and you would do that.
And we'd move the petabytes of data over.
In the same, so Blue Waters is literally in the same room where the LSST computing is. And Blue Waters 2, or whatever they call it, is going to be a factor of 100 more powerful than the LSST machine.
But it's being designed such that the LSST storage facilities are directly connected, wired directly connected.
I don't want to use the word directly, but I would say well connected.
Is this documented somewhere, like a list
Yeah.
of possible facilities?
Yeah, no, that's okay. Just another point. There will be other data access centers throughout the world, and at some point soon there's going to be a process by which data access centers are selected. So I know that the IN2P3 in France is almost certainly going to be a data access center. But there will be other data access centers probably throughout the world that will make it. But that's not fully worked through yet.
If you want to see kind of what the U.S. cyber infrastructure capacity is, just Google for exceed XSEDE. That's the NSF side.
But I think to drive that forward, I think there's a lot of, especially for solar systems used to doing things on a small server by yourself or with a small group of people, we're not used to using these facilities for that. And I think one of the things that I've found hard is that it's very hard to get any of this documentation anywhere on an easy website, where it's like, well, go to this document and this PDF and that PDF and that PDF. But it's very hard to find, here's, the overall basic information. It's a lot of here's the details in the documents. Like,
you mean as in how to access a data access center, how to run your
what is a data access center?
Like
which ones do you have? Well, if it's going to be at this other place that that you can apply for, well, maybe we should start learning how to use that. Those things I can't find online. Where I know what prompt and data release and user generated are, but
they are still being worked on. I mean,
right.
It is still a process. And in terms of using the LSST development platform, Desk and the commissioning team have really only just started quite recently to use the development version. So you're not really very far behind in that sense. I don't think you need to worry, but I think at one of these meetings, possibly in the future, it would be good to set up an LSST development platform and get you to, say, work with the Kepler data. The reprocessed HFC data.
So we have set up a Jupyter Health environment with LSST stack and necessarily specific ones. So you have it for using. Or
a data set that is more appropriate to your science.
Yeah, I wonder if, not to again get too deep into the weeds, I wonder if something like, to use the NASA Planetary Roses, sort of wording, right? If something like a PDART written by, key members of the consortium with, collaborators that say, what we're asking NASA for is the money to run these things and produce for the community. Here's the list of all of the deep stacked KBOs, but that's not gonna, that would be inclusive in some ways. If it's here's the stuff for everyone to use, it would be not inclusive in other ways if it's here's the group that's just gonna propose and get the money.
And you have the data rights issue, which is that you don't have data rights and it's something that's proprietary. Certain things cannot be publicly released. But again, our data set is pretty much public.
Right.
So deep stacking detections, I don't know if we can see.
That's not good.
No, right. So we can't move into the Minor Planet Center until that data is public.
Okay. That depends
or
on
papers published.
But you
or
can't.
whatever,
But you can't apply. You can't propose to do stuff in PDART until the data is published. Anyway, so
Yeah.
Sorry.
And so it's good to have discussions on this. I mean, I want to know where you're at and what you don't understand and what I need. Okay, so since we're moving on to the data access rights, I added this in following a discussion at dinner last night. And who was you guys? So I just thought I'd quickly add this in. I'm not going to go into any more details in this at the moment because there is a very detailed document that is being worked on, which I believe is going to be announced at the Project and Community Workshop, and a first version is going to be distributed there, which discusses in detail the data access rights. But just as an overview, there's world public data and there's proprietary data. World public data can be shared with everyone. Data rights are not required. And this includes the alerts, which are immediately world public and can be shared with anyone. So the content of an alert packet, and I'll go into that in just a minute, can be shared with everyone. Data releases are world public following a 2-year proprietary period. That means that for the first 2 years, it's only data rights holders, and after that, it's fully world public. So when a data release becomes fully world public, there will be 2 more reprocessed data releases with 2 more years of data on top of that. Education and public outreach, anything that falls under EPO and can be accessed via the EPO platform is world public. They will be working with a subset, very small set of the data to showcase some of the really nice examples of LSST to the public and for science communication. So what's proprietary can only be shared with data rights holders, and this includes, for the alerts, it includes the archive of the issued alerts. So there will be an alerts database and a prompt products database. The prompt products database contains catalogs and images, but the alerts database is the archive of the issued alerts. This is proprietary. The prompt products database, the difference images, the source catalogs, the pre-covery force photometry, this is proprietary. The data releases, again, as above, images, catalogs, as well as the reprocessed prompt products. So with every yearly reprocessing, we will reprocess the prompt products using the best calibrations available and all the information. And that will come out as part of a data release, and the data release is private. Sorry, it's proprietary. And the science platform is also only available to data rights holders. This includes the computational resources, the mini broker, the portal. These are available only to data rights holders.
Sorry to hang on this, but the first one, alerts are immediately available to the public. I was under the impression that because of the 300 to 600 gigabyte a night stream, that is the alert stream, that it's actually only going to be funneled, that the full raw alert stream is only going to be funneled to a few specific
community brokers. Yes.
Brokers.
Yeah.
So does that not immediately mean that a statement as written there is false? Because no one, if you're not one of those, if you don't have access to one of the community brokers, which is a proprietary thing, then no one can access.
Community brokers are not proprietary.
Well, so the stuff that the UK is producing is specifically for the LSST data holders, their community broker.
Right. So my understanding from Eric's talk is that, when we asked, is that when community brokers get picked, there will be some preference for some that will be issuing more to the public beyond just data rights access.
I don't know what that means.
So that you can have a broker, right? And if you can say, I'm only going to give to people that have LSST data rights, and another broker can say, I'm going to transmit this and parse it, and anyone can see it. And there will be a preference for at least a few to be worldwide, anyone can see it. So LSST is basically just sending this out and saying, okay, we're just sending it out. We're going to let you things connect to it. And some of those things will be selected or have priority preference to be selected as one of those few community brokers if they say, hey, I'm willing to give this to anyone who wants to connect to us.
I mean, you as a user can't just connect to the LSST alert stream. There will be community brokers. I will talk about the brokers in a minute. There will be community brokers that will be selected via a proposal, and they will receive the alert stream, and users will interact through this. Now, if you're coming back to the LSST example from the UK, I was talking to those guys quite a bit in Europe recently. They had the idea to link in the alerts with the prompt products database to extract the force photometry and then to make a more encompassing alert to then distribute that. I don't think they realized until we discussed it that that was actually proprietary information. So that would be an example.
But they've always been of the opinion that the only people that would have access to receive it, because of all the other proprietary stuff that has gone into it, work is LSST data rights holders.
Okay, that wasn't the impression I got when I discussed with them.
So that's actually what Stephen said specifically in his talk. This will only go to LSST data rights holders. So that's why.
Okay, so.
But anyway, I'm sorry. I'll be sure.
No, it's okay. I mean, I remember when I talked to Ken Smith in Italy about this, that wasn't the impression I had, but I should follow up on that. If that's the case, that certainly won't be the only community broker if they're selected. Yeah. Remember, no community broker has yet been selected yet.
Yes.
The UK proposal is very advanced. They've done a lot of good work, but nothing has been selected yet. And as Meg says, there will be preference given to those that will make everything public.
For example, is an NOAO Antara is full public. There's not you can connect to it or ask it to send. There's no limit on that one, for example, because NOAO has restrictions about doing things like that.
So I assume this is obvious, but maybe not.
Maybe not.
So a derived product made from a proprietary source is no longer proprietary, right? If I am a rights holder, I have the latest data release, I write a paper about what's in it. Is there any reason that I couldn't then publish that paper and publish it open access if I want?
Yeah, that's a topic that's going to be discussed. It's being worked on with this paper. Colin, do you have any information about that?
The current philosophy behind that it is still proprietary up until the moment that you publish it. Once it's in the journal, then it's your derived data product is available to the world, so you can.
But there's also
I believe the thinking is that if you publish something that you could work backwards from and get the raw data, then a derived product must be something from which you cannot work backwards and get the raw data and then start doing a reanalysis on the original data. That's what I understand. Yeah.
If you
Yeah.
take an entire LSST catalog, add the number 2 to it, and then publish it.
And say, I added the number 2.
Yeah, sure, okay.
Yeah.
Publish the size distribution of type of objects in each document.
That sounds
At least from my reading of the draft document that I saw, but it
Sounds
still
like a
does say-
liaison or something.
Yeah, Mario?
I have a question. So can I create and publish a catalog of applied minors?
As an example of something strange.
I think
Catalog.
the catalog, I find all of them. And I come up with 30,000 like binary candidates, and I publish that as a template and ask people to go and follow up.
Yeah, I think
But
so.
I mean, does that
Sounds
sound
very proprietary.
is that proprietary, or does that become public?
So you can't figure out what the picture looks like.
Army dense
Yeah.
score and
So it's not proprietary.
it's 30,000.
Yeah, I have to admit, I hesitate to give an answer on that. I'd really like to wait for this.
Because the reason I bring up this case is this was a typical case for. And this is enabling there are subsets and slicing this in these ways.
It would, yeah.
I see both sides.
Okay, listen, I'd like to come back to these issues about data access because it's a topic that's being worked on in detail in LSST at the moment, and there are a lot of open questions, and questions like this are very good, and I'm not sure that they're all solved yet.
Yeah.
Yes.
I don't understand exactly how brokers work and how
Mhm.
public they are, but it looks to me like your first point and the two boxes are kind of in conflict. I mean, what's to prevent the public from harvesting the alerts and creating a shadow alerts database?
It could, but you have to have a lot of compute resources to do that.
Okay, but it could be done. So
You could connect to your community broker, I guess, and record every single alert that comes through.
Oh, but you can't build a single.
But
That would be totally true. That would make it a problem.
would essentially make you a broker, and it's not a trivial thing to set up and do.
But it's totally within your data rights.
Totally
but
within the
is
world.
there a broker that is going to, a public broker that's going to have all the alerts and stream them out to the public? There will be that.
Yeah, there will be.
So that could be done. So if somebody else decides to do that, then your first point is kind of moot, right?
No, I think it's just what this means is that the LSST archive can't be queried if you're not a data writer.
Which is a perfect reason that somebody outside of LSST would.
Yeah,
would
so
build that.
heads up, this is actually one of the considerations of this conversation about exactly that at the Canadian annual technical meeting a month ago. Literally just, so this is why I had that question at the beginning, is it really true that alerts are public or not? Since they are, the CDC might very well put in a proposal to do exactly that for all Canadians. Including the ones that have not purchased.
So just subscribe to a community broker, take all the alerts, and record them in a database.
Correct.
I'll follow up.
Yeah, it would be worth looking. As a Canadian, I don't think they should do that because it seems like it shouldn't be allowed, but that's LSST's problem, not Canada.
Well, I mean, if it's made available, then that's made available. So, all right, we'll move on from that. So just a bit more detail about the prompt data products. The goal of these is to enable transient and time domain science that requires rapid follow-up. Okay, that's the goal. Rapid follow-up is the key thing here. These are single epoch data products, images and catalogs, and alerts, and they're produced through difference image analysis. And you can see you take a template, you subtract an image, and you get an alert. The trigger for a prompt data product is a detection in a difference image with a signal to noise ratio greater than 5. This is a configurable number. This is where it's set at the moment. And it's meant to do things like flag new astrophysical objects or to flag changes in the flux of existing or known objects. The whole point behind the prompt data products is to trigger follow-up, to make sure that we don't miss interesting events and that we can easily work with other observatories to follow up on them. In terms of solar system science, I think Mario showed you this yesterday. I'm not sure if you want to go through it in detail again. This is the difference image analysis source table. So these are the parameters that are extracted from a difference image analysis with respect to that are important for solar system science. So there's a lot more than what's just in this table. You've got the usual piece of information like position, time of exposure. There's an association of a detection with a known object or a known solar system object already. There's information about deblending, etc. This is a very long table, and you can find the whole details in the data products definition document. But with respect to solar system science, there is trailed models are applied to the difference image analysis sources, and there are parameters, the trailed model parameters are stored here in this object. So that's what you get in real time. The daily orbit catalog, this is the SSO object table. You can, again, this is just a snippet of what's in there. This is produced by the moving object pipeline, which runs within 24 hours on all new difference image detections the night before. So it computes the orbits and physical properties, and these are available in the prompt products database via the science platform. So if you connect the science platform to work, you can query this database and extract the information that has come from the moving object pipeline analysis. One thing I just wanted to point out here is that there is an open ticket in DM at the moment about reviewing this schema. And I noticed that there is a Google Doc associated with this, and that this group has been working on reviewing the parameters in here.
We have a poll that went out, so we actually sent it out to Mario, and we now have a new proposal he's working on.
Yeah, that's one of the hacks for this week.
Okay, so I just wanted to just point that out, and that I guess we're waiting for feedback from you on that.
So we just sent the feedback, yeah. So it's now in Mario.
Okay, so Mario will keep us informed in data management. Seeing this. So these are in the prompt products. These are the two tables that are of most interest to solar system science. So the alert streams themselves. So an alert stream is produced by the nightly processing of LSST images. So we have these nightly images. We do difference image analysis. We find detections, and each detection in a difference image analysis creates an alert. And these alerts get sent out on alert streams out to community brokers. So an alert is triggered solely by the detection in a difference image analysis of a difference image analysis source with a signal to noise ratio greater than 1. That's all that's required to trigger an alert. There's one new alert per DIA source detection, and we expect something like 10 million alerts per night. We don't do any classification on this, so the alerts will contain all types of astrophysical events. This sort of filtering will happen in the brokers. And the goal of these alert streams is to very rapidly transmit information about new detections to enable downstream classification and follow-up. Primarily what this is for.
Part of identifying an alert is filtering out artifacts, right? So,
yes.
So this is.
So this sort of thing is done on the LSST side already, and there's do you remember do you remember what the purity and the purity
there was some fairly high requirements.
Yeah, on purity and completeness. There is
But in essence, it's going to be similar to ZPF. You're going to get a word packet that's going to be secondary voice for it, so you can do that as well.
Yeah.
It's another ignorant question following up, and I don't know what ZTF does. So if the night is kind of iffy and there's cirrus coming through and things down, is that where the I forget what they call it, the other telescope?
The auxiliary
telescope, is that where kind of that fits in to go, okay, this 10 sigma change is a cloud?
Yeah, so I didn't go into anything about the auxiliary telescope. The auxiliary telescope, for those of you who don't know, observes the sky at the same time as LSST, and it measures atmospheric parameters and other things that are used in the pipelines and the calibration and the reduction. I'm not sure what information will be available in the nightly processing for this.
So things like clouds are not expected to, the clouds should be calibrated out. So you shouldn't expect to see brightness because a cloud came over. But the only difference there is going to be higher.
Okay, so it's not going to be, hey, this cloud moved in, there's going to be 7 gazillion triggers that show up.
No, that information is taken into account.
But the auxiliary telescope is more about calibrating band passes of a very active. Care less about these serious do putting some.
But I guess one question was the auxiliary telescope information is not available fast enough.
Okay, so what's in an alert packet? So alert packet is a text file containing the data and the associated schema for one difference image analysis source. And it contains at least the following. This is not necessarily exhaustive. An alert ID and an alert in the prompt product and an ID in the prompt products database ID. So as a data rights holder, you can associate an alert with the products that are stored, persisted in the prompt products database ID in the database. In terms of the science data, you'll have the full record of the difference image analysis source that triggered that alert. So that's everything that's in the table that's in the data products definition document. You will also have the entire difference image analysis object or SSO object that it's associated with. So in the nightly processing, if an SSO object exists already that can be associated with this new detection, it will be associated with it, and you will see that in the alerts. If not, it will be associated. If it's a new detection, it gets associated. A new difference image analysis object is created, and this will be processed and analyzed during the next 24 hours by the solar system processing to see if it's consistent with a solar system object. You get up to 12 months of all the previous DS source detections, so you have this time series of information. The matching IDs from the latest data release will be provided, and 12 months of the source records. And there'll also be a variety of summary statistics computed on the time series that will be made available as well. In addition to this science data, you will get cut out images of the difference image and the template image that we used to create this detection.
Quick question.
Yes?
So the 12 months of data, the DSOR's detections, is that force photography? Basically, whatever data or detection was associated with the object of the...
That's right, yes.
Related question. I mean, I can see for sidereal sources how you do bullets 3 and 4, how you do that for moving objects, where your guy is not in the same place as it was last night or 2 nights ago.
For that tomorrow.
So for moving objects, in essence, this is about resending detections that were previously done. So if we have moving objects, we'll give you all the detections from the previous 12 months of that object. And we won't enforce atomic moving objects because the error is right.
Okay, so that's only in
identified something. Yes, so it's for identified.
Right. Okay.
So, one of the UK's software products that's been funded to go forward, as far as I know, generate deep stack cutouts of moving objects. It can stack a whole bunch of detections of whatever source you want to look at. And the idea being that this is going to be an automatically done thing for whomever, so that we can just go get them. So I'm wondering, given that is exactly what Dick was just talking about, bottom point there, can we somehow include the previous stack? If you've identified an alert item with a known moving object, and that stack has already been in existence, can we set it up such that that gets included as the bottom item of this list for the alert?
In the alert packet?
Because it's free. That was the whole intent anyways, right? Stack of what? Stack of moving objects.
You mean you want the previous observations of it?
No, I want the stack.
Of images, you want the image stack.
The last 100 observations of the stacked together. It was the idea being commentary activity and stuff like that. But it's going to be done for all moving sources. And the idea was to do it to set up the processing power to do it automatically anyway. So if it exists, if we have additional information like that, can we not include it in the alerts?
That's what we would do.
That's the user. I think that's the user generated.
That's the community broker.
Yeah.
Right. So it would be at that level, right?
Yeah. That would be, I agree. That would be something that the community discuss with the community.
Or a mini broker, right? Because
or in the
then.
Well, the mini brokers up here.
No, but if I'm on the deck, I can then with the mini broker say, okay, well, I know this thing with a solar system object. They'll clear those images and do it. So it doesn't have to be that the mini broker does that, but it can tell me which ones are the comments I should go run that script and then send you the email with those things in it. But I think that sort of concept that you can do that stuff together is quite dynamic.
Thanks.
Is that something that you said that the UK one of the brokers was considering? Let's see. Who's working on that?
Alan Fitzsimmons and I are working on that.
Okay.
And then there's a couple other groups in there that are working on.
Yeah, to me that's added value that might be added.
I mean, that would be a question for all kinds of other data products that we'll have for each of these objects that we'll have to, I assume we will have to assign ourselves to these alert packets. Like, like you're not going to include like known rotation periods or something from in the alert packet, even if it's already known.
No,
Right, so the correct thing to do then is to set up a simple broker that assigns the stack to an SSL object record such that when an alert comes, the broker pulls that piece in. And
yeah, for
okay,
example,
great.
we could do
Thanks.
that. Yep. Any other questions on alert packets? All right. So how do we distribute these alerts? We've sort of covered a little bit of this already. Alerts are distributed to community brokers that filter and classify events to enable science. And some of the examples that we've just been discussing. So just a quick through, we generate the postage stamps, we put together the alert packet, this goes into a message queue. Everything that's put into the alert is stored in an alert database, which is not the prompt products database, it's the content of the alert packet that I just showed you. And these are sent out to either a simple filter service, which goes to the LSST mini broker, which is tightly coupled to the LSST science platform, or these go out to a set of community brokers. So as individual scientists, you will access these alerts through either a community broker service or through the LSST science platform. So a bit more detail about the community brokers. These are the primary endpoints of LSST's event streams. So key point is that they are provided by third parties. LSST itself is not responsible for building a community broker. Again, the goal is to trigger additional follow-up observations, and these brokers can be enhanced with a lot of extra functionality as the community brokers, as the proposals choose themselves. So cross-match, for example, with astronomical catalogs and alert streams that exist already. You might want to cross-match these with the ZTF alert stream. You might want to bring other catalogs from surveys in to do more detailed classification. So then they can use this to go on and filter and classify events according to the sort of science they want to support, provide machine learning classification of events. They could, for example, provide hooks and user interfaces to users to add their own filters and classifications in there, and so forth. There are many things that these communities brokers might choose to support. An important point is that everything is transmitted through a VO event format and the IVOA protocols. So coming up shortly, there will be a call for community brokers, which will be selected through a proposal process to receive the full stream of LSST data. And this is something that's in preparation at the moment. So I believe that there's a document coming out soon to describe the process, and then the call will happen probably next year, I think. I think by the end of, Mara, do you remember? I think it's the end of 2022. They were thinking of having this. It's not imminent, but it's
there's a whole talk by Eric Bellin on the alert stream, and he talks about the timeline for this and when it will be out. So you can go to lsst.org/scientists, and the slides and video from that talk. And
yes, that's the PST talk.
Yes. So that will get that he talks about the schedule and like has some more specific details about what will probably be in that draft call. No,
not from LSST.
So you get to do a whole bunch of work for free.
Well, write a proposal.
Right.
Well, I believe that
if you're selected, then
if you're selected, you'd want to have the funding to do this. I know that the UK community has got funding from the UK science committees for their LSST proposal, which is really, you can find a lot of information if you want to look at the UK one. I'm not really familiar with any of the others so far. I just know that one's very advanced if you want to have a look at what they've been doing. So yes, it does require getting funding from elsewhere, not from LSST.
So we probably need to move on in a couple minutes or in case with questions of whether or not
sure.
If you want to get through.
There's a little
Of order, how many community brokers will you?
Okay, something 10, like 10 would be an absolute maximum. We're looking at 3 to, the number is not determined. It'll probably be something like 3. It won't be more than 10. 3, 5, something like that. Good questions? So the mini broker, this is a simple filtering service, also known as the alerts filtering service, which provides real-time access to a subset of the alert stream through the LSST science platform. It's available by the US DAC science platform. You can have user-defined filters which act only on single alert packets. There will be some pre-defined filters. There will be no cross-matching service. There will be no exclusive classification. So it's a smaller service that's meant to provide access to the alerts, but it won't provide the full functionality of a community. There will be support for, at the moment, the numbers are 100 simultaneous users with 20 alert packets served per user per visit. There will be some limits on runtime and bandwidth. It's only open to data rights holders, and it's tightly coupled to the LSST science platform. This is something that's still being discussed. The development is ongoing. It's based around science use cases. And yeah, this is a continuing discussion. I was asked about LSST side filters. What can be done on the LSST side in the alert stream? So there's a formal requirement that the capability exists to have LSST side filters. Some predefined filters will be provided, but it's not yet decided what they will be. I think more of a question back to you in the community is what would you like to see? What would be of interest to the community and to many people? I mean, we don't have to go into this now. I think Meg wants to move on. But this is something to think about, and perhaps over the course of this meeting we could discuss this a bit further, what you might like to see as a predefined filter in an alerts filtering service.
Sounds like a good unconference session.
Yes. There you go. Unconference session. What would you like to see as a predefined filter for solar system science? I was also asked about what it would entail to set up a dedicated broker for solar system science. This is an open question. Okay, so I've just put up a few points here for discussion. First of all, you can always write filters for the mini broker, but the performance requirements are such that it's not going to allow for a lot of filters. So this sort of comes back to the previous question. What would you like to see in terms of predefined filters? What would serve the community? And another question I would ask is, I mean, do you require a full stream broker to serve solar system science? I would say probably not. The community broker proposal call will open up the possibility to receive a filtered stream and not the full stream. So that might be something to think about in terms of what you might want for solar system science. So again, unconference session, something to think about. We can come back to the slide and use that as the starting point. Okay.
So, Leanne, can I just have a question? Because I don't know the answer. So are we interpreting how many simultaneous users? Are hundreds, and is it one filter per user, or is it?
No, so
how are we interpreting the 100 simultaneous users?
Well, that would be if you had 100 simultaneous users, you would then have one alert per user, one user. Not that much. So, but if you had less, there'd be more. It's
I'm
quite.
so confused. Can one user have 9 filters, for example?
Yes, but then there would be a cap.
Then
Simultaneous.
Then you might hit
Could.
your number of internal alerts limit faster.
Yeah. But I
You
could
have
have
fewer, but
But
more
if I have
acceptable.
10 filters for very rare events where each filter has a likelihood of field, then
Yeah.
That's
what I understand from Eric. But this is also an open question. All open and being discussed. Okay, so this is actually, in a sense, another talk in itself. So we can stop here, and we can move this to an unconference session. Basically, Meg gave me and Mario a whole lot of questions from you guys about how would I do this with the alerts, how would I do that. So I've worked through about 5 examples that were given to me as to how you would enable this science with an alert stream or with the prompt products. But I think that taking more than enough time already, and we could move this if you want to discuss it into one of the
That would be great.
sessions.
There's probably a lot of questions.
But you have these slides, and I've just taken an example and worked through it.